All right, welcome back. Today we're going to complete a strict review note session because we studied these parent functions earlier in the fall. You should see this as a fairly recent review or a review of a fairly recently covered concept. So we should not have very much difficulty with this, but if you do have questions, please make sure you get those questions answered because while this is a very simple process, we have to make sure that it is correct so we don't miss any of these types of problems. All right, so the first thing we're going to do is we're going to graph the parent function for both the cubic and the cubic root parents. Zoom out a little bit so we can see all of it in its entirety. So you'll notice that you've got your critical values here, and those critical values will help you graph appropriately using those stretches and compresses. Because it has no restrictions, the domain and the range are both all real numbers. In this case, I used interval notation, negative infinity to positive infinity. Cubic and cubic roots are inverses of one another, so that's why we are going to take a look at them together like this. Again, here's your critical values. Because there were no restrictions on a cubic, the cubic root has no restriction either. That's why it's all real numbers, negative infinity, positive infinity. You want to use those critical values when you are graphing it, so please make sure that you are graphing this accurately. Don't just throw anything up on the graph. Please graph it accurately. We'll be expecting to see that on assessments if you're asked to graph. I'd like you to complete this quick write, but I went ahead and gave you some starter words to get going with this. Go ahead and utilize the vertex form of the cubic root function to kind of help you get in the right direction. We'll be talking about that tomorrow when you return to class. All right, so what I've gone and done here is preloaded everything, so now let me zoom in on it so you don't get the opportunity to copy it all down. Okay, so the first thing I've done here is I have put the parent function's critical values in table number 1. That's going to help me set the stage for the transformations in table number 2. So you can compare them to each other to see how it is that they line up after transformations have occurred. Using your quick write from before, you should be able to quickly identify that there are 2 transformations. The first one was a vertical stretch by a factor of 2, and the second one was a movement to the right 2 units. From there, you can create a domain and range or create a graph first, and then from there make the domain and range. But because there's no restriction, that's why you're going to get this function here. Notice I still have my critical values. They're just stretched. Instead of over 1, up 1, I go over 1, up 2. Instead of going over 8, up 2, I go over 8, up 4. And instead of it being at the origin, it is simply shifted to the right 2 units. So you can see how the actual parent function relates to the transformed parent function. That's something, again, that we studied, but I just want to keep that fresh in your mind so that you're recalling that when it comes to tests and quizzes. Again, we'll start with the table of the parent. That's going to be these critical values here. And then we will insert the table value for the transform function, therefore making it easier for you to see the connections. Notice it goes to the right 1 and up 2. That's why what was at 0, 0 is now at 1, 2. That's typically the easiest place to see your transformations occur. Okay? The next thing we want to identify is that their transformations are a vertical reflection, moving to the right 1 and up 2. You can create your domain and range first because the domain and range has no restriction, or you can graph it and then from there create a domain and range. See how I've used my critical values from my table? Okay. Instead of going up over 1, up 1 to the right, I'm going over 1 to the left, up 1. That gives me my reflection vertically. What was over here is now, or sorry, down 1. Let me say that correctly. I apologize. Instead of going over 1, up 1, I go over 1, down 1. That gives me my vertical reflection. You now can start to see that vertical and horizontal reflections are pretty much the same thing as far as the graph is concerned. And there's no stretch or compression, so the only thing left is what was at the origin is now right 1 up 2. So we can utilize those transformations to help us graph. All right, finally, our last little part, we're going to use our graph to help us determine the equation. So, like I was saying before, all we have to do here is determine where it was and where it is now. So that means it goes down 2. And from there, what was over 1 up 1 is now over 1 down 1. So that is going to be a vertical reflection. And you'll notice that the critical value holds true. If I would have gone over 1 down 2, then I would have had a stretch of 2. Over 1 down 1, 2, 3, I would have had a vertical stretch of 3. But instead I went over 1 down 1, so that means there is no vertical stretch or reflection, or vertical stretch or compression. So that means all I have to do now is use these two to make my equation. So let's start with f of x, and let's use the vertical reflection as a negative. And we're using the cubic root parent function here. It moved down, not right or left, so that's why it is on the outside. Notice there's no restriction, so that means I'm going to use interval notation here, and that's going to be negative infinity to positive infinity. Likewise, the range is exactly the same. All right, finally, question number 5, describing the transformations. So we're not transforming from the parent function. We're transforming from one function to another, so you have to be careful about this. Luckily, there's no stretch or compression on the first one, so the stretch and compression is the number we see. And that is on the outside, and that is a fraction, so that's going to be our vertical compression, and that's going to be by a factor of 1/2, or by a factor of 2. The compression means that it's getting smaller. All right, now what we're going to do is we're going to identify where it was and where it moved to. So it was right 3, and then it moved left 2 from the origin. So that means the total movement from being all the way over at positive 3 to moving all the way to negative 2 is a left motion of 5. And then we notice where it was and where it is now. So it was at positive 1 up here, and it went all the way down to negative 3. That's a total change of down 4. So that's just being observant to the changes from one graph to the other. Like I said, today was going to be pretty simple, pretty straightforward, but if you do have any questions regarding this material, please make sure that you get them cleared up, because this is a very important part, and we don't want to miss any easy problems associated with these polynomial functions.